Should we get started? Yeah. Folks, welcome. This is the Distributed Mobility Management Group. I'm Sri Gundavalli.
Yeah, 大鹏 here.
And our area director Suresh has a family emergency. He's not able to be here, but I believe Terry will be here at some point and he'll be monitoring this meeting. So today's agenda, before getting started, okay, this is the note 12 statement. This meeting is governed under certain IETF policies and code of conduct. Please be aware of those rules. These are framed in a number of IETF documents. Please read them up. And there's also IETF IPR policy. Please be aware of that policy. And sorry. So before the meeting, I think we need some note takers, please. Any volunteers? We need 2 note takers. You can look up here. Any volunteers? Absolute silence. Okay, so who did not send the slides in time? I think yesterday 6 p.m. was the deadline, and at least I know, as far as we know, Satoru-san gets the honors. So, Satoru-san, would you be able to take the meeting minutes, please? Okay, thank you. And we need one more. Anybody else? Okay, all right, I think maybe Carlos? Yeah. Okay. Shunsuke, I think this is your first meeting, right? It will be a good experience for you if you take some notes. Yeah? Okay, thank you so much. All right. Okay, so this is let's review the status of each IETF documents. First one is the on-demand mobility management document. So this completed last call. We sent to IESG and there was some feedback, and authors have not yet resolved those issues yet. But today, there's going to be a presentation, and I think Brian Haberman is one of the reviewers. He's going to be here as well. He's going to give his feedback. So let's wait for that. That is one document. The second one is the DMM deployment models. I think the question is, we are wondering whether, we should continue with this, or, is it truly needed? I think that is one thing, but let's hold on to this, I think, for now. But we should, at some point, we need to make a call whether we should, is there value in this document, or we should, take this up and fold into other documents is one of the key questions that, we are struggling with. The other thing, SRV6 mobile user plane, I think this is on a good track. Overall, there have been some good discussions. But after IETF 102, we haven't seen many discussions, but overall, this is on a good track. I think the authors are putting a lot of efforts. And I think we are quite happy with the progress. And there's another document, which is the PMV6 DMM document. That is, Carlos says the first version was posted. 00 version was posted in the last meeting, right after the last meeting. And I think today there's going to be a presentation. Let's review the status of that. And the FPC document, this is one document that went through significant amount of contributions from the authors. Lots of work went in. I think it's time to wrap this up. And again, I think one thing we are struggling with this is we need to get some feedback from the from the working group. We need more discussions, more comments. I think the authors have put in a lot of efforts, but I think we need some good reviews. right? And moving on, I think there's another, the distributed mobility anchoring. I think this is, I think we, over the last few meetings, I think like we said, essentially we were not happy with the quality of this document, and so we had to appoint a editor for this, and Carlos kindly took over, and he did a complete rewrite. The document, what was 80 pages, came down to literally like under 20 pages. So we are overall it's a quality document at this point, but at the same time it also resets everything in the sense that we again need a new set of reviews, because we are almost at a 0.0 version, but because I think it's a rewrite of the document, but technically that document is stable, right? I think, but we need some reviewers. I think any volunteers, anybody can review this document and provide some feedback. I think that's maybe after Carlos' presentation, let's identify some reviewers. And I think the one more, the MNID document is under the maintenance category. This finally is going to be published as RFC 8371. Congratulations to Charlie Perkins and others. I think from what I remember, this document was, it's been there for a while. I believe it was published, if I remember, if I can, my daughter was born and now she's a teenager, so it's as old as that. So license statement, I think there were a few LS statements. I think one is there was a 3GPP LS request from CT4 working group. Mainly, essentially, it's an update on the work that they're doing with respect to mobile user plane optimization. And they wanted, some feedback from IETF and like an update from IETF on what we are doing and like how it, how we can, help those efforts, right? We drafted a response, and the response was sent to the working group, and we got some comments. And I think we have a 5-minute discussion slot just to make sure that the working group is on the same page with respect to the response that we are sending, right? And I think let's discuss that. And finally, I think these are the new set of essentially new set of documents that were published after IETF 101. Right, a few are mainly the SRv6 based, POCs. I think some again mostly around user plane optimization. I think because that is a burning topic in 3GPP, and I think that's a key point of discussion, right? And I think let's some of these documents have allotted time slot, and we will be discussing those documents. And I think with that, let's start our first presentation. It will be Lyle on the FPC work. Okay.
Good morning.
Just 1 second. Actually, I think blue sheets, please, everybody, please sign the blue sheets. I think there should be two copies. Just one. Please, thanks.
All right, good morning. I'm going to talk to you about revision 12. So, and the good news is 40 slides, 10 minutes, you should be fine. So, basically, can you help me with the line as well?
Yeah, I don't know what's.
So, just a reminder, right? So, this is about control user plane separation, as well as the fact that we're trying to really give a base abstraction model. So, we're not worried about specifying protocol here, but we want to basically enable a many-to-many client to AEM model. So, we have the concept of multi-tenancy, and essentially nothing's changed, right, in the last several revisions from this concept. It's been around since version 4. So our job in this document is to give you kind of the base semantics of things like selection of data plane nodes that are actually providing forwarding services, as well as just basically implementing your desired forwarding policies and configurations. So from 101, So from 101, right, what we're really doing is we had a few action items. So we had the concept of service endpoints, and we eliminated those. That was actually discussed in 101. We actually put that out in the mailing list during 101. Essentially, we had endpoints in groups. And then by looking at our primary use case, which is triple DS that we were looking at emulating, we were able to successfully eliminate the endpoints as a structure. So and then show compliance with things like triple DS and selection. We were also able to demonstrate that the client should do the selection as well as the agent. So the information model is there and it appears to be sufficient with what we currently do in production and what some people are contemplating going into subsequent implementations. So we had to review the Yang model for NMDA compliance. Really the end result there was basically explaining how we're compliant and really where NMDA and some of the concepts apply. If you've read the document, the Yang is in the back, so the compliance information as well as the guidance is in the back of the appendix. So we did change a few configure statements that we used to throw for catching that. So as we submitted, so that's actually why it's version 12. It's meant to be version 11. So we missed a couple of
Just that.
All right. We did add more examples. We only had a few in the beginning. Part of this was as we went from 9 to 10, it was a major rewrite. And so we went in and made sure we had an example for each of the major data structures as well as the life cycle. As we talked about in 101, we're policy-based, we're a template-based design. And so we wanted to make sure that we were completely backed up in terms of having examples in the document. So it's a little bit bigger, but what we did was we basically reduced it using editing and then added more back from the examples. So it's a lightweight update to the spec. So if you've read version 10, it's very consistent with that. The biggest change, as we talked about on the mailing list, was service groups, and I'll just kind of blast through these really quick in the interest of time. But what we're trying to do here is really enable the selection. So once again, we're interested in making sure there's sufficient information available for this to be done, but we're not worried, since we're not specifying a protocol, in terms of who's actually doing the selection, the clients or agents. So in several examples that we did in terms of bouncing against 3GPP, as well as IETF applications in production, it seems to hold up quite well. As we talked about before, we're template-based. So we talked about this in 101, but we do have a lightweight language infrastructure, and this is actually then used for the base information model to keep the front section short in the information model, and then if you really want a verbose dissertation, the Yang will be more than sufficient. We then broke out the entity and config data. Policy really hasn't changed, so thank you. So policy really hasn't changed. What's actually happened here is by adding the examples, right, we're able to talk a bit more about how the usage applies. Down in here, we're able to show more of the life cycle. So once again, look to those examples. Those are going to help you out quite a bit. But we're able to demonstrate full life cycle models in the document. Data planes, once again, haven't changed. We do, right, with the policy configuration, this was something we did not have time to talk about in 101. Just as a reminder, the biggest change that we did from version 9 to version 10 was we put the policy templates underneath the data plane and eliminated some of the old concepts that was there. So basically, the system's really simple. You specify your policy templates. To install them on the data plane node, you set up a DPM policy configuration, and then that's your pre-install. So for those of us who have ever been wondering how pre-installed rules work, this would be kind of your answer. So you can actually pre-install, and then when it comes to the mobility context, you can then reference those pre-installed rules that are here on the data plane node. You can also have policies on the data plane node that just apply to all traffic. So this is just a general policy application. You don't have to think about it in terms of a mobility context. The context, as the structure implies, right, is there. And we see, with respect to kind of our overall design, you'll see we can pull in mobile node specific policies, the DPN specific policies, or domain specific policies or templates, if you actually use the domain to actually select this. This is for those of us that worry about roaming. You have the specifically assigned policy that's available that came from the DPN. So we're looking for, and this gives you your traceability, make sure it was actually installed. And then within a specific service data flow, you can actually have a service data flow policy, and those are typically dynamic rules that are built on the fly. Most prevalent application is Vultee, but you'll see that it's all basically there. So that's it's with the exception of monitors. Those haven't changed in a long time. Watch what you want, how you want it. This now shows you the operations. So this is kind of the overall, I'll leave this once again for your reference, the overall life cycle of installing, probing. The one thing to note, right, is even in the, the base semantics of the protocol, everything comes back via a notification. So you actually use a probe to stimulate a response. You don't get the data back in a response. On monitors, configure results and result notifications have not changed in several revisions. And then probably the big thing that we talked about in version 10 was how operations have been modified. So we do follow Yang patch style operations at the FPC semantic level. And this allows us to actually do some interesting things. Probably the one that's the most interesting is the move. So the idea of moving policies between data plane nodes in a single command, as opposed to kind of picking them up, telling one guy he's uninstalling and telling the other guy that he's installing. So we're able to actually run a lot of this in the design. The inserts and the merges are also interesting. So it allows us to kind of set up a situation with the operations where we can minimize the over-the-wire communication as it's eventually realized in a protocol. Next steps, as we've talked about, we're done, guys. So we're not intending to add any more. We've made our editing passes. We've closed all of our action items. So at this point, what we really need, as was said, was we need reviewers, and to get a good couple set of reviews so we can go ahead and get this thing to last call.
Okay, thank you, Lyle. So Lyle, can you comment on so as far as you're concerned, all the issues have been addressed, right? That is one thing. Now, you've been, working on the open source efforts. Can you talk about that a bit?
So we still have out the 2 existing implementations, and they're primarily version 4 based, because a lot of activity happened from about version 7 to version 10. And then, as we said, really version 11, and then when we made the error with 12, 11, and 12 are really error correction of 10. So the code base has been out for, it's been open source, like the Open Daylight one, I think, for now a year and a half. And we've got different people using it at various stages. So we've even learned that there's some operators who have actually done a field trial where they inserted it, tested it out, and pulled it back. So it's fairly mature.
Sure. But so do you plan to update that to bring it to the current version?
Yeah, absolutely.
Okay, cool.
Because right now, just to let you know, on the Open Daylight, and it's actually it's more of a Java issue, and this is the first time we're trying call processing with Yang, right? So that's kind of a new concept. So right now we're doing about 1,000 TPS with a triple redundant, SDN cluster, right? Because we're worried about 5 nines as an operator.
Right.
And that's requiring about 12 CPU cores. We'd like to see that shrink. And the shrinkage is going to come from the fact that the code base we were using was using TCP and other items. So we want to do the updates because the protocol also has many optimizations like the merge and the replace. Right. So we know we're going to get some efficiencies there, and it's an opportunity to upgrade our protocols. So.
Okay. All right. So I think we need some reviewers. Maybe let's identify some reviewers, and we can send it to issue last call.
Right.
Thank you, Lyle. Okay. Next one is V6 extensions for DMM. Carlos, you have 10 minutes.
Okay, I'm Carlos Bernardos. I plan to use less than 10 minutes, so should be fast. Can you
This is not
help me
aligned
with this?
We need to do this, man. Okay.
Next one.
Yeah. You can go to the next slide.
Okay, so basically, briefly remind the status of the draft and the history where we started with this and where we are now. Then again, I will very quickly summarize the operation of the document for use for those that are not aware, and then I will basically ask for reviews, which is the main point of actually this presentation today. So in terms of the story of the draft, this draft was adopted as working group document after London meeting, although has been there for quite a while, since the beginning of the DMN working group, we started working on this solution, and we even had a couple of kind of demo events collocated with IETF meetings. So we have implementation available on this document. And the solution is basically PMIP-based extensions for DMN. So very simple. We basically push the mobility to the edge and allow to have more than one anchor working simultaneously for a given mobile node, by the mobile node having multiple prefixes allocated. So basically, every time a mobile node attaches to a network, it gets an IPv6 prefix, anchor at that access router, and continues using the former prefixes that were allocated in previous or by previous access routers. So basically, it's that simple way of ensuring reachability of the prefixes, and then by the time the device stops using those prefixes, continue using the new ones that are allocated. So the solution is partially distributed in the sense that we have a distributed data plane. So the anchors are at the edge, and then we have a kind of centralized control plane, an entity that takes care of keeping all the bindings of the mobility bindings and ensuring that the different access routers get the proper information to establish the tunneling and the redirection of the packets. So here just a bit of terminology. So we have a couple of, the anchor, the router, we call it mobility anchor and access router, but it's basically the regular router that is concentrating the access router LMA and MAC functionalities depending on the prefix and the mobile node. And then we have this entity that is a centralized control plane entity, what we call centralized mobility database. And it's basically, as I mentioned, keeping the bindings from the mobility of the different mobile nodes. So here, maybe you can try to, just a picture maybe, but not the, so basically this is a simple picture summarizing what happens when the device attaches to the network, attaches to an access router, and then the signaling is sent to this CMD, to this centralized control plane entity, which is the one that creates the binding and replies with the PBA to the router. So basically this kind of as the CMD is the LMA, and the MAR at this point in time is actually not even a MAC, it's basically just anchoring the prefix that is locally allocated from that access router. Then if the device moves, maybe you can also put a picture only. So in that case, if the device attaches to a different access router, it will also signal, that will be detected, that will be signaled to the CMD, to the centralized mobility database. And that guy will be the one signaling to the different anchors that are available or are active at that time. In this case, the previous one and the new one. The new one will allocate a locally anchored prefix, and the other one will set up a tunnel with the new point of attachment. In this case, the device will have two addresses, one anchor at MAR2, that is no need for any tunnel, anything, it's just a regular router for that prefix, and one anchor at MAR1, that the traffic will be redirected to the canal location, which is via MAR2. So basically, it's extending PMIP to support multiple anchors. And next one, which should be the last one. So in this revision, since the adoption, we address all the comments. We got actually quite a few revisions during the adoption call from different guys. So we address those reviews in the current version. So the document, although has been presently adopted, is quite mature in the sense that we had a lot of revisions when it was individual. So we really need some reviews to move it forward. So that's what I would like to ask the chairs if they can ask for reviews. I can volunteer myself, for example, for the previous one to review. If somebody from the team can review this one, these kind of things, I guess, would be helpful.
No, I think we definitely need more reviews. Folks, any volunteers? Thanks. All right.
So
Folks, we need more contribution. I think, we cannot move this work without your contributions. Please, whether you like it or not, we need to review the document and post comments. Please, any other volunteers?
Thank you, Dan.
Who is that?
Danny.
Oh, Danny. Okay, very good. So we have Danny and Lyle.
And you can
Okay.
put my name on the other one,
Okay.
the live one.
Okay, all right. Okay, okay, very good. Thank you. Okay.
Okay.
So so thanks, Carlos. And I think that's about it, right? Yeah. Okay. Very good. So next one is so this is SRV6 for mobile user plane. It will be Pablo. Yeah, I think just once. Yeah, here Pablo, you can take this. Okay. Yeah, this is an update on the working group document. Yeah, please go ahead.
So good morning, this is Pablo Camarillo from Cisco. This is an update on draft IETF SRV6 mobile user plane. It will be quite fast. The summary of updates from version 1 to version 2, it was in essence just to clarify some of the questions that we had on the mailing list. The first one of them was to clarify the type of PDU session supported. So in essence, this is IPv4, IPv6, IPv4v6 Ethernet and structure. And in the draft, you actually have which SRv6 functions is supporting which kind of PDU session type. The second modification that we introduced in the draft, well, we added an appendix where we added the current implementations. So we have an open source P4 code that is implementing the SRv6 functions that are introduced in this document specific to mobility. And we also have 2 ongoing POCs for MCORD and Open Air interface, which we documented in a separate draft, but we are just referencing to it. We also added some references to what technologies are used for network slicing. So this is referring to other drafts. And we also added some control plane considerations. There was also another, where we fixed some typos as well. And there was, additionally, there is one more change in the draft, which is just a clarification on how the interworking mechanism works. So the n.m.gtp6 D function and how does it work based on a question that there was on the draft. So as next steps, what the authors, what we are working on is on how to support the different GTPU messages and extension headers. So for example, the 5GS container. We are still analyzing how to do this. We believe that maybe we do not need to modify the GTPU extension header, but this is still being discussed. If you have any input, please, or any feedback, just please come to us. And then there was also another question on how we support different types of EPF. So for example, uplink classifier EPF or branching point. And we need to add an illustration on the draft on this topic that we will add and we are working on. So that's it for the update. Any feedback is welcome.
So Pablo, with respect to where you are with respect to the document, like how much work is left and,
So I don't think there is that much work left on the draft. I would just say the most important topic is just to extend the function coverage. We also received some comments on the motivation of this work, and for this reason, the authors have worked on a separate draft, which we just posted last Sunday. For this one, we are not presenting. That is explaining the use cases for SRv6 mobility,
okay.
And that's it. But I think it's...
Is there any deployment of the open source you mentioned?
Of the open source
implementation, yes.
So the open source implementation are still under development. It is not fully finalized on the 2 of them. They are work in progress. The first phase is completed, but still there are several phases, and this is documented in the POC that will be discussed later.
Okay. So has there been any feedback from 3GPP on this document? Any reviews, Satoru-san or anybody else from 3GPP? Any feedback, any reviews from 3GPP folks? Please.
Satoru Matsushima, SoftBank. Specifically, this document does not reviewed by 3GPP folks, but certain portion of the feedback we already have from offline discussion. But later on this, the agenda has the feedback on the analysis side. So then that will be kind of the SRP6 will be taken into account by them.
Okay. Okay, thank you. So we need to keep this for we need more reviews. Okay, please.
全程雄黄花位 also working in 5D standard in 3PP SA2. I have viewed this paper before for the I don't know which version, maybe version 1. I think a lot of consideration based on the 4D GPU function and the 5D. There's a lot of new function have been introduced by the 5D. For example, the reflective QS. Now I think that the paper had not well documented this new function. Immediately consideration how to support this.
Can you, excuse me, can you please repeat your question? Sorry, I didn't hear the last part.
I said some new 5D introduced some new function for the user plan function. For example, like a reflective QS indication and QFI, the QS flow identity. This new identity have been introduced for the new version of GPU, but I say because the CD4 has not defined a new version GPU, but we need to include this new function and identity in the new user plan protocol. But based on I checked the version, this new function has not been discussed in your paper.
Thank you for your feedback. So this is part of the work that we are analyzing as part of next steps. So as part of analyzing how the GDP messages and extension headers, we also are analyzing how to encode XGFI information, for example.
Yeah.
Thank you.
Okay, thank you. So I think, Junshun, can you post your comment on QFI to the working group? Maybe you can post a comment, yeah. Okay. So that's about it, right, Pablo?
Yes.
Okay, thank you.
Thank you, George.
Pablo. I think the next one we have distributed mobility anchoring. This is the revised, yeah, okay. Oh, okay. Oh, that's on.
Okay, hello. This is Carlos again. So I'm briefly update on the distributed mobility anchor draft. So just the status, as Sri mentioned at the beginning, we have a significant update for London. So we went from more than 40 pages to around 15. So trying to improve the readability of the document and also improve the chances of people willing to take a look at it. So that was the main goal when we did that. So we try to simplify the complexity, simplify the drawings, try to have a maybe less ambitious scope, but more useful. And since then, we had a review from Marco that was very, very useful, and we have a couple of revisions since then, trying to address the comments from Marco. So we try to improve the focus of the document, so let's keep it simple. That was a principle that we tried to do, or we had in mind. And basically, we believe that now the document is much easier to read and is more complete. I don't know, Marco, if you have the chance to take a look at the revision, that will be helpful if you, in the future, if you can. We can discuss offline about that. And also the draft is available on GitHub in case somebody wants to contribute. We can do it directly there. So this is the table of contents of the version 08. So the one that we did for London. And this is the table of content of the version that we have in version 10. There is something that is just crossed. This is because there is a typo on version 10, something that shouldn't be there, but I will remove that after the meeting. But basically what we try to do is to identify the kind of three anchoring cases that we have, which are what we call the numeric case, the mobility case in which we use traffic radiation, and the mobility case in which we have anchor relocation. This basically came up from the review that Marco did, the suggestion that he proposed to keep that structure or to use that structure. So these are the three cases that we consider. So the numeric case is there is no need of address continuity. The mobility is either not required or handled by another layer 4, application layer, whatever. So basically, there is no mobility at all. The mobile node, every time it moves, it changes addresses. That's simple. And then we have the mobility cases. And in that we have two subcases. One is where we have traffic redirection. So when the mobile node moves to another point of attachment, the traffic for the preface that the mobile node was using is redirected to the current point of attachment. So this is basically the case of the draft that I presented before. And then there is the other case in which the anchor is actually relocated. So that's more complex and requires some support in the network in order to actually move the anchor of that the mobile node is using. So those are the three cases that we describe in the document. So as before, again, next steps, we believe that the document is now stable in the sense that we reduced the complexity. We got a initial review from Marco basically saying, if I understood properly, otherwise correct me if it's not your point, that we were on the right track in terms of simplifying the document. Now we fully address the revision of Marco. We need more reviews because, as we mentioned, this really had a lot of changes since before London. So now it's something that is much simpler to read and much shorter. So I would like to really ask you guys to take a look at the document, because otherwise we cannot do anything else. I mean, from my side, I'm done at this point.
So thank you, Carlos. So other than the rewrite of the document, what are the technical changes? Did you make any changes to can you comment on that?
Basically, I summarized those in London. We remove all the stuff related to hierarchical mobility, anchoring things. With the NEMO part, we also simplify. So basically, we focus on the very simple things, like those are the three cases. Those are the things that you need to do. Those are the entities, referring to the terminology that is in the deployment model, I think, document. So we try to use the actual terminology that is kind of adopted in the working group. And it's really simple. So, we just remove all the fat kind of thing and focus on the three main cases that are those three ones. And then we provide some pictures on, like, okay, in this case, this is the entity, this is the entity, this is the signaling that will be required. That's very helpful.
Okay.
So maybe I have one proposal. Since this document should be, aligned with other solution documents, so may I propose that the FPC document authors and also the scheme routing document authors help to review that to make sure that is aligned.
That would be really helpful.
Yeah.
Okay, we can do that. Okay. So any questions, comments? Okay. Thank you, Carlos. Yeah. Okay. Think so. The next one we have on the agenda is Danny is going to present an update. Oh, oops. Status. So we also have Brian. Thank you, Brian, for coming. Yeah. So Danny, I think you're going to give an update on where you are with the ESG comments. And, yeah.
Yes, I'll provide a short presentation because earlier this week I met with Brian.
Yeah, you're roughly like, I think we're okay time wise. I think you're roughly we can use roughly 10 to 10 minutes on this.
Okay, I hope I won't need 10 minutes. Anyway, we had a discussion early this morning. Just to remind the group, the document went through a preview by Brian, and he had 5 comments. We listed the comments on the list and the initial response. And since then, we had some email exchange trying to resolve these issues. And can we go to the next slide? Okay, so I would like to present 2 issues in which we have action items to change in the text. I guess the rest, if people are interested in the rest, they can read the presentation. So the first one, and I think the most, the one that was initially acknowledged, is that the draft uses the term IP session continuity. And IP session is not really well defined. And the comment was either define what IP session is, or better yet, use a different term. And initially we provided various alternatives, and I think that we came to an agreement that we will use the term session continuity rather than IP session continuity. And in addition to that, there were some text changes as a result. And I pointed out here the crucial one, and that is rather than having the text, the ability to maintain an ongoing IP session, since we're changing IP session, we change the text to the ability to maintain an ongoing transport interaction. Now, Brian and I agree on these changes, but we felt that we need to present that to the working group and receive approval from the working group on these changes. So hopefully we can do that. And the next issue is, I think, issue number 3, I think slide 6. No, not this one. No. Okay, this one. The feeling was that, okay, we described the extensions for the socket interface, but the feeling was that the description of the whole picture, meaning, okay, an application requires something from using the socket interface. How is the interaction with the network? What does the network do? What does it reply? And things like that could be better described in the draft. So we agreed to, and initially I wasn't sure I wanted to do that because we didn't want to impose a specific solution for how this would be done. There could be different alternatives, but eventually we agreed that maybe better explanation could help. So we are going to add an example of some message flow indicating that this is an example. It's not the only message flow which is correct. There could be others, but hopefully that will improve help people understand the draft better. So these are really the 2 action items that the writers have, and that was the agreement in our Monday morning session. And my next step is to update the draft, hopefully as early as next week. And I'm not sure about the process. Do we have to go through work group last call again?
Depends on the changes.
Okay,
That's all.
so I will post the changes, and if anyone has comments, I'll be glad to respond. Yes.
Bob Moskowitz, HG Consulting. I lived through the OSI wars. I'm a stacks person. And going back to your comment about IP session, you just say session. You can't really say transport unless you can assure you do not disrupt the transport port assignments, which is an OS concept. So the only thing you can say, I believe, is session continuity. IP continuity only applies if, because of whatever, you actually maintain the IP addressing, which you actually don't. So being a survivor of gossip, I would say that you should just say session continuity and leave it at that.
Can you move back to the first issue? You were referring to the first issue, right? Yeah.
Session
More.
yeah.
Yes, that one. For those of us who survive gossip.
So what is your comment? You
It
don't
should
like
just
the
be
term session continuity?
Just session continuity. That's all you say.
Oh, okay, so that's
Just,
what,
just it, not transport continuity, because that's an OS concept. You can't make any statement about transport continuity, and you are definitely not IP continuity.
right, so first of all, we don't have transport continuity in the new text.
Well, you mentioned that in your talking.
Oh, I'm
You may-
sorry.
You
I'm
maybe
sorry.
have misspoke at that time.
I'm sorry. Okay, so I agree. To be very accurate, you're right. But there is one mode in which the IP source address is maintained, and that's part of the service that the network does provide.
Then you clearly state it is IP session continuity in that case. If you are really maintaining that IP address in that move and you're not disrupting it, then you can make that set. Of course, what is an IP session?
Exactly. So
You
this
know.
is what we're trying to avoid.
Yeah. So again, those of us who survived the OSI wars
Okay.
and really lived all those debates. Yeah, it's
Okay.
just say session. Just
Okay, okay.
Thank you. Brian, your feedback, yeah.
Brian Haberman, and I definitely do not have a yellow dot. But I will say that since this document is an AD evaluation, before the working group actually goes and does anything, they should wait for feedback from the AD because he may have additional comments that he wants you guys to address. So I told Danny this the other day, I am not the gating factor. I just make the reviews. It's up to the AD who actually asks for the reviews to decide which ones are important, which ones aren't, and what comments they want to address before they actually move it to IESG or to IETF last call.
Okay, so Brian, but with the changes that you agreed upon with Danny, if those changes are made, are you okay moving this document forward?
So my basically issues 2, 3, and 4 were driven by the fact that there was not enough descriptions in the document for someone to actually look at it from the outside and say, okay, I understand how this concept is supposed to work. If Danny goes in and he puts the changes that kind of give that conceptual example, then that should help with that clarity. Because, it's hard enough for somebody to review it who's not involved in the working group, but they're involved in the IETF. If you ask somebody or actually in the int area, if you ask somebody to review this from, say, the transport area or the security area, they need that context, right? And so I would much rather see you guys fix this clarity problem here sooner rather than later, so that you don't get 3 discusses from 3 different areas and then have to try and go back and retrofit everything.
Yeah, very good. Thanks, Brian. I think that helps. I think, Danny, definitely there's work cut out for this. I think, you need to discuss with Suresh, but I think, so 3GPP is currently referencing this document, right?
Not this document, it's referencing the
The
other
other
extension,
extensions.
which references.
Yeah,
this.
sure, but the terms
Yeah,
are the basis. Yeah,
It's referencing this work. That's
yeah,
what it is.
I agree with that. Yeah, okay, fine.
Okay.
So, I think
So
let's
my
wait.
next step is to update the draft, and
Yeah.
I will post it and
Yeah.
hope
Okay.
for some comments or.
Yeah, let's
or
wait
the-
for, AD.
or the AD
Yeah,
and
yeah,
shares.
Yeah, sure.
Okay, thank you.
All right, thank you. Danny, I think next one should be Marco, right? We have the mobility aware floating anchor, Marco Levish. Okay. Yeah. Yeah, I think we can try.
Okay, so this is a brief update on the floating anchors draft. And since we have 10 minutes, so if you need details, please have a look to the draft or to Sri's presentation from last IETF in London. So for today, we just want to highlight a little bit the basic principles of that approach and how it fits into the overall picture of the data plane discussion. So the draft with the basic principles and operation has been published before last IETF and has been discussed. In the meanwhile, we received some very valuable comments, which caused some discussion on the mailing list. Some of the comments went a little bit ahead of the basic principles, but very important to see how that concept fits when being deployed with a cellular architecture. So in the next revision, we plan to publish soon. We would like to address most of these items at some level. All right, so the main objectives in general is to meet the requirement of future connectivity services, which will comprise a huge diversity in device types, different traffic mix, mobility communication patterns, etc. Also, network slicing for customized provisioning of network should be taken into account. Just a reference to a current study in 3GPP about ultra reliability and low latency communication, which really discusses also the dynamicity in the network by moving end devices, but also changing data networks. So that peering seems to be important, in particular for edge computation and services. So that's our main objective. In general, we look at an access independent data plane. We'd like to leverage the currently being discussed different data plane protocols and the programmatic tools in the view of a customized data plane. So by the architecture we propose, we enable optimized routes between a mobile node and one or multiple correspondence services. Well, moving from a centralized or fixed anchor to decentralized data plane, that's the original requirement and objective of the DMM working group, which is on stage since a while. And last but not least, in the draft, we address and would like to strengthen the discussion on how that approach can be deployed and integrated tightly or loosely with the mobile cellular architecture. So, as said, we want to move from a single mobility gateway to programmable edges, whereas the edges are, on the one hand side, the mobile edge, which is here. Sorry for the small picture, we have a bigger one on the next slide. And on the other hand side, the correspondent edges, which is one or multiple correspondent nodes or services in a data center. So by applying default routes in between one or multiple correspondent edges on the mobile node, we have a low number of data plane nodes which are impacted. So in case the mobile node moves and gets a new mobile edge being assigned, we apply host states at the correspondent edges and enable optimized routing in between the multiple services and the mobile node. We have an example on the next slide here. So to enable this traffic steering, the approach is compatible with any of the currently being discussed data plane protocols. So the draft currently focuses on segment routing, because here we have the flexibility in choosing intermediate hops between the correspondent edge and the mobile edge. But other proposals like locator rewriting or any ID lock separation kind of approach can be applied here. These states at the correspondent edge are or can be of transient nature. So whenever the mobile node gives up its IP address and IP address continuity is not required anymore, the correspondent edge states can be diminished. Last but not least, by the programmatic flexibility, we can go beyond the actual traffic steering and additional states and policies for metering, QoS, monitoring, reporting, gating, whatever, also paging support can be taken into account and enforcing any of these edges, either mobile or correspondent edge. Brief example here, very similar to what's represented last IETF. So the control plane, let's not focus too much on that here, but we have the control plane leveraging topology awareness and location awareness. On the data plane, let's assume the mobile node attaches to an access gateway 2, which is its IP address anchor. So here in the example, the green IP address with prefix 2 from gateway 2 is the one that's to be maintained. So IP address continuity is to be supported when the mobile node gets a new access gateway being assigned. In addition, the mobile node may receive a local prefix, which is routable, but valid only as long as the mobile node is attached to access gateway 2. So in that example, the mobile node has communication with 2 correspondent nodes, one you can see here and the other one here. So since the IP address is from access gateway to its network, default routes apply in between correspondent nodes and the mobile node. So what happens if the mobile moves and gets assigned a new access gateway? So per the requirement, the local prefix, the yellow one, is deprecated and the mobile node gets a new one, but the green IP address is to be maintained. So we call that IP address continuity, somehow related to the previous discussion with Danny's draft. So maybe in terms of terminology, we have to line it here. The important point is that
the control plane can leverage the programmability of the correspondent edges by enforcing additional policies for traffic steering. So what we do is basically enforcing states at the correspondent edges, enabling segment routing, ideal locator separation approaches, tunneling, whatever you want, to steer the traffic to the mobile's current access gateway. So by that, we can enable optimized routing. The feedback we received was very valuable. So since the draft focuses on segment routing, there was a request to have at least a section about how that works with other data plane protocols like ILA, Lisp. Then there was a request to add more information about additional functional or non-functional aspects like device dormancy and paging. So that's very important if you integrate that approach with a cellular network where the mobile may enter a discontinuous reception mode and the exact location of the mobile node is not available in all the data plane nodes. So that's something we consider very high importance, and we will add a section on that here. So the big question on the mailing list was how the correspondent edges get information from the control plane for traffic steering. So the current draft focuses on a reactive approach, which is working, but improvements can be made here. So we are currently discussing and evaluating different proactive approaches just to avoid packet reordering and that kind of things have been addressed in the feedback we received. So that's very valuable to update the draft. There was a question of, so if we move the access edge to the very much extreme, so to a base station or something, that access edge may be access specific, but we could clarify that if we have a loose coupling between the programmable data plane node at the edge and the actual radio technology or fixed line technology, so there is no tight binding between that approach that we present in the draft and the actual access technology here. Same, the interfaces, so how do the correspondent edges receive the policies for traffic steering and additional ones for metering, whatever, from the control plane. So in the view of cellular integration, cellular technologies and architectures are very particular. But we have some ideas which we would like to discuss with you folks, how that picture could fit into a 3GPP next-gen architecture as an example. And this is also pretty much related to some proposals that are currently being discussed in 3GPP, where the data network plays a role in influencing the traffic steering policies. Last but not least, so correspondent edges have states. So when do we actually delete the states? Is that something enforced by the control plane? Is it soft states? So there are a few things that should still be thought about and actually captured in the draft. So more comments are, of course, appreciated, and hope during this week and then online we can have more discussion about these ideas.
Okay. Yeah, thank you, Marco. Is there any comments for this draft? Any questions? Okay, so I'd like to ask how many people read this draft. Please raise your hands. Okay, so a few. So maybe I think for the next step, the authors may keep update on the mailing list and trigger some discussion there as next step. Yeah.
Yeah, as an author, I think I'm an author on this document. I think any reviews will be appreciated. Yeah.
All right, thank you.
Okay, thank you, Marco. Liaison. Discussion.
Yeah, next one is the liaison statement from 3GPP on CT4. I think we had some discussions on the mailer, but I think it will be very good. Satoru-san, do you want to just talk about it? Then we are. So yeah, I think you don't have slides on this. Yeah, no slides. Yeah. Yeah.
Hello, Satoru Matsushima, 3GPP Hackathon. Can you show the doc?
Unfortunately, we did not make a slide for this. Sorry
Okay.
about that. Yeah.
I think, how do you,
Isn't letter. Okay, you want to? Yeah, does this help, Satoru-san?
yeah. So, this is what I presented in last IETF meeting in London. What we ask to IETF DMM is to provide any information regarding the user frame protocol. So then we can see the many activity on this. So I really appreciate all the effort on the IETF side. So that's the discussion and the outcome of the those of the discussion really useful. So if you can show the draft liaison statement for the CGPP, at least I think the content is a good level to show the current status of the IETF side.
So this was our response. I think
Yeah.
the response that we drafted and what was discussed in the mailer was this. I think there were 1 or 2 minor comments, but overall, this is what is, what we have. Yeah.
So as we requested to IETF to provide any information, and with the some additional information, we will work on the to figure out the criteria to compare the candidate solution, and then need to list up all of the candidate from the IETF side. So I think that the liaison reply text and the content, including the document pointing to the internet draft, will be sufficient and suitable for the liaison back to ICPP for us. Thank you.
Okay. So any other comments on this LS response? This is what is going out. I think, there were a few comments. Anybody who commented on the mailers, do you want to say anything or? Yeah. Dave, yeah.
Hi, Dave Allen Erickson. Do you really want to be pointing them at individual submissions, or do you want to hold this to stuff that at least the working group has agreed to work on? Because, I mean, they're looking, this is an issue of managing expectations. And if you're giving them stuff that has no status, is not on track to have any status, then you're not sending them the right message.
I think fair point, Dave. I think this is what, I think last time what we discussed, we are not pointing to any solution documents. If you look at these 2 individual documents that we referenced, I think we are referencing 3 documents. One is a working group document, which is on track to become a standard. I think that is the services.
I have no problem with that, because that's setting the right level.
Absolutely. So the next 2 documents are requirement analysis and comparison of various approaches. So these are neutral to any one specific approach. So I think given that these documents are neutral, and we are stating that IETF is not going, a couple of points. We are stating that IETF is not going to pick any one document as the document for this. We are going to standardize potentially maybe more than one solution, more than one protocol, right? But the analysis, the requirement analysis, that we are referencing them because that may be useful work and we are neutral to the solution. So that is a thought process. So there are folks who have asked to reference individual documents, but we refuse to list them out here.
Yeah, just to me, I don't know how a document can be a completely neutral analysis. Except, if it hasn't been through the process, it is probably incomplete and hasn't been fully commented on because it wasn't adopted by the working group. So that for me is a bit of a red flag. And like I said, you're setting the wrong level of expectation as to how this stuff is going to progress in the IETF. 3GPP, they're trying to work the schedules. They've got a lot to do on 5G. They're doing a lot of polling of the industry to see what is there that they can consume.
Right.
And something to me that is not working group status, just by definition, isn't consumable. So.
Okay. Thank you, Dave, for that feedback. Yeah.
Hi, Sri. This is Uma from Huawei. So this response is good, very good actually. But the only comment is, please say that this is initial response. There are various proposals that need to be thoroughly discussed. Some of the proposals are recently published, and some of the proposals are published like last IETF, but not significant discussion happened. So it say that this is initial response. As we can send an updated response based on the progress of some of the work. For example, I'm a co-author of LISP. This Dino presented last time. So there's some more work need to be done on that. So
Uma, we posted the text to the working group for for any changes, right? I think so. We are not editing this at this point, right? I think if there were any comments, we gave a deadline of last Friday, right, to make any suggestions, comments. So we are just going by what was discussed in the mailer. So if you have comment now, it's maybe I don't know if there's you need to extend the we can probably extend it for another few days for additional comments. But if you have specific comments on the text, whatever that is, please post it to the mailer.
No, I said the text is fine.
Okay.
Please say that this is an initial response. There'll be an updated response of maybe after 1 month or 2 months. I don't know.
But even that has to be in the text. So.
Rashid coming from Huawei. The 2 points, the U-plane analysis basically is neutral in a sense that we are basically trying to pick up the 3GPP requirements and conduct a study on what GTP does and what the extensions to GTP will provide to do. It is not favoring any particular solution. It's basically completely studying the 3GPP requirements, and that's why it's neutral. As far as the optimization, optimized mobile user plan is concerned, there are different solutions that we are considering in that draft. However, we are not particularly advocating a particular solution because the final decision actually is based on the analysis that 3GPP will conduct on its own. And as a result, all we are doing in there, we are trying to compare different protocols with existing GTP scope and behavior. That's why even in the optimized mobile user plane, we stood away from doing any providing any final decision in which one of these things we favor in terms of 3GPP study items. So they will pick up what needs to be done. They will conduct a study. We are merely providing information in there.
Okay, thank you, Arishma. Yeah.
Thank you. My name is Georg Meyer. I'm the 3GPP liaison person to IETF, and I just wanted to say that the discussions that are going on in CT4, they are focusing on this, and whether you have here a draft with just a name in front of it or a working group agreed draft or whatever, adopted draft or whatever, I think that's at the moment secondary. You need to go on with your work and you need to stay in exchange with CT4 if I guess you're serious with this work, and we need to find out the stability of the work that you are doing here and how it can be adopted in CT4 at the moment. I agree we have very tough timelines in 3GPP, but nevertheless, we started the study now, and if you take longer, then maybe it's not release 16 where this will be adopted, but release 17 if there's an agreement to adopt anything from DMM group outcome. But I wouldn't go into a discussion where practically our timelines, the 3GPP timelines, push you too hard to complete your work. Make sure that your work is stable, and most of all, make sure that the informal and formal communication between this group and CT4 is well and alive. Thank you.
Okay, thank you for sharing that view. Yep, Danny.
This is Danny. So just to add a little bit to what Georg said, and to answer Dave, 3GPP is well aware of the statuses of the different drafts in IETF. So they understand the difference between an individual draft and a working group draft. So they won't be confused by whatever we provide them. And I also agree that we need to continue the work, especially as it's of interest for CT4. And I think Georg is being a little polite or over polite. There is an issue of work in IETF tends to be in a much slower pace than what is done in 3GPP, and we should do this work as fast as possible so that it could be seriously addressed in CT4 for release 16 or maybe release 17.
Okay. Dave.
Okay. Hi, Dave again. Just one other thing. I remember we had the discussion of what class of information we would liaise in London. And what it was is we would not provide analysis. We would simply provide raw information and let CT4 do the analysis. So we seem to be going backwards on that.
That is not true, Dave. I think if you read the response that, that what you're seeing on the screen, we are clearly stating that, we are going to standardize, potentially more than one solution or approach. We are not going to say, we are only going to characterize the solution approach, but we are not going to say that this is it, pick it. All we are going to say is do some technical, like, approach 1, approach 2, and characterize it in a very neutral, but it's up to them based on the system architecture, which one to pick.
Okay, so I just want to go on record of having expressed the concern, and my understanding was that was the agreement. So I hope whatever we do is consistent with that.
No, absolutely.
Thank you.
Just Georg Meyer again. I just want to say, yes, I'm a polite person, maybe too polite for IETF. I'm sorry for that. One issue is, of course, how fast you want this work to conclude and to possibly be adopted in 3GPP. That is up to you how fast you can do the work. And I don't want to influence anything on that. I think you're progressing at the moment at a very high speed, and you have to be careful that your work still stays stable, right? The other thing is that the study we are conducting now in CT4 relies on that you have a certain amount of stability in your work and clarity also in your work. So you need to progress it in a way that CT4 can evaluate the outcome of your group and see if it's really valuable or possible to adopt it in 3GPP. The final decision whether we will go on with GTP or with one of your solutions, that will be taken by CT4, or maybe not only CT4 but also other groups in 3GPP. So from that perspective, I fully agree with what you said, that you can only provide us a set of different solutions and we will evaluate them in 3GPP, but sort of the evaluation of these solutions is not part of DMM, to my understanding. Thanks.
Yeah, fair point. Next time you can pick up the gloves, boxing gloves from the registration desk.
I think people have proposed some two issues. One issue is that 3PP have very quickly working style than IETF. But I say this reason says that this select DTPU for the release 16. In my understanding, even for the release 16, the 5G standard is not stable enough. In SA2, there are over 20 study items is currently studied in the SA2. There's a lot of new feature were introduced in the release 16. For example, there's a traffic steering between different access technology between 5G, 4G, and Wi-Fi access. And there's also actual reliability and low latency communication. In that way, they will introduce two or parallel GPU connection for one UE to improve the reliability. So there's a lot of new feature and function that are going discussed and studied in 3PP. So I think it's very hard for our DMM to follow the steps or the progress in 3PP. Even we working in IETF, working in the 3PP standard fund is very difficult for the progress of the standard 5G standards. So I agree with George that we provide our text as current liaison, and we continue to identify the real requirement from the 5G Release 16. Then we progress our solution. In current 5G Release 15 is not enough to support the 5G requirements.
Okay, thank you. So any final thoughts?
Sorry to come again.
Yeah.
I just want to avoid that we have a 3GPP discussion in this room. So what SA2 is currently doing is studying an enormous amount of new features, and nobody knows what will be the outcome of that, right? And it's not your job to evaluate this at this moment. And you can look at that, you can draw some conclusions from that, that's fine. But from my understanding, let's take CT4 as the single entry point for the communication between with DMM on this topic, and let CT4s evaluate what the real requirements in release 16 will be. This will change over the time as other groups in 3GPP will progress, but let's keep that discussion out of this room, please.
No, I understand. I think that's absolutely a fair point, yeah. Dino? Yeah.
This is Dino. If this working group is going to interface with 3GPP, I think we need to go a lot faster. And if we can go faster and impress 3GPP, hopefully they will return a response just as fast.
Okay, thanks, Dino. I think, yeah, Shun's next one. I think with that, I think we are going to extend so I think whatever you guys have posted, if there are any objections to the LS response, please, send it to the mailer. And I think, but we will extend the deadline by another few days, but that LS response will go out this week. Just one second, which one is?
User plan.
Yes,
user frame.
Yeah, one second. Oops. So this is a new document. I think this is the analysis document. Shinsuke, you're going to. Yeah.
So good morning.
You have roughly like just one second. Yeah, 15 minutes. Yeah.
Okay, so good morning, everybody. I'm Shinsuke Homo from MTC Laboratories. In this presentation, I will talk about the user plane protocol and architectural analysis on 3GPP 5G systems and report the feedback from 3GPP. Firstly, I will introduce background and overview of this analysis work. So we mainly have two motivations on this analysis work. First is showing understanding level on IETF side for 3GPP specifications. It will be help to make 3GPP folks recognize the IETF proposal was considering, and it will be help to understand CGP specification for IETF folks. And secondly, clarifying problem spaces and improvable points is very important for proposing new protocols to 3GPP, and we believe that this document should be part of reason reply. So in this work, we analyzed GTPU specification from TS29281 and 5G architecture requirement from TS23501, 503 to 503, etc. In addition, we extracted some evaluation aspects for studying user plane protocol from the analyzed 5G architecture requirements. From this work, we provided 13 GTPU observations, 6 architecture requirements for user plane, and 7 evaluation aspects. In addition, we could find some potential gaps between the GTPU as the current user plane protocol and 5G architecture requirements. So in the following few slides, I will explain the content of the analysis draft. So in these two slides shows GTPU observations. For example, GTPU is basically a point-to-point tunneling protocol and sometimes supports point-to-multipoint tunneling. And in the 5G architecture, QFI is used for identifying the PDF session, and GTPU can convey the QFI with extension header, but the order of extension headers is not strictly defined in the specification document. This is example of the GTPU format, so it will be help to understand what GTPU packet. In these two slides shows architectural requirement on 5G architecture. So, for example, in 5G, 5G architecture defines the PDF session, 4 types of PDF session: IPv4, IPv6, Ethernet, and unstructured. So, user plane protocol must convey this PDF session. Or 5G architecture allows flexible UPF selections, or putting multiple UPFs in the data path. So this may cause increase of number of data paths or tunnels. And 5G architecture allows to aggregate multiple QoS flow indicated with QFI into a PDF session. So user plane protocol must convey QFI information. So this table shows evaluation aspects extracted from the architecture requirements. So as I mentioned in the previous slide, user plane protocol must convey must cover every PDF session time. And as nature of the path, user plane protocol will be required to support much point-to-point protocol tunneling to reduce load of management of path state. Also, in the 5G era, various types of access network, including other operators' network, will connected to the 5G core. And so user plane would be required to support dynamic MTU discovery and adjustment. QoS control is still a very important point. And in addition, so network slicing will be we assume that network slicing may have big challenges. For example, network slicing is a logical network, and some slices share the same physical resources such as UPF and physical link. And in some cases, several network slices has different forwarding policies. So user plane protocol may be required to convey such a different forwarding policy for each network slices. So in the following slides, I will report the feedback from CGPP CT4 meeting. So there was a CT4 meeting last week, and we obtained some feedback from CT4 folks. So these two slides describes details of the feedback. And you can find the original document from the bottom link. In this presentation, I will introduce the two two characteristic feedback. First is about the the place of QFI. So in the analysis work, we couldn't find the description about the order of extension header, but in the recent specification document describes a note 4. It recommends that QFI information should be contained in the first extension header. Second is implementation of GTPU in the 3GPP. So TS 29281 defines GTPU is P2P tunneling protocol, but 3GPP allows to use GTP like multi-point to protocol. So like this figure, so several UPF may use same TID for the PD session. So from this feedback, we could confirm there are clearly gaps between GTPU and 5G architecture. And we believe that this work is in the right direction. So lastly, I talk about the next steps of this document. So for improving this contents, so we need more feedback and a review and feedback from both IETF and 3GPP side. And we believe that this it should be part of liaison reply. And also, if this document is you think this document very important or useful, so we would like to request this document be working group document. That's all. Thank you very much. And you can find the examples of image of evaluation aspects in the appendix. Thank you very much.
Okay, thank you, Shinki-san. So any comments?
Rashmid Akavane from Huawei again. So I will encourage everybody in this group to actually read this analysis, and we are trying actually to use this analysis as a base for our own work in terms of conducting competitive analysis between different approaches that you're talking about the other draft. So this will basically put a groundwork together so that we can have a common ground analyzing all those different protocols against the same thing. Basically gives us an apple-to-apple comparison. So any solution that comes to the picture basically will be looked at from this document perspective and see first whether we can satisfy all the analysis and the comparison that we are trying to make based on this before going forward to 3GPP. We say, okay, these are the set of basically protocols that we want to take to you guys to look at. We first do our own work to make sure that everything actually is in order before we go to 3GPP with a list of protocols for them to consider. That's basically the work that we're trying to do here.
Thank you.
Okay, thank you, Ashwin. Dave?
Okay. Dave again. My understanding of what we discussed at the last meeting was we would not try and do their thinking for them. And I get what has just been described to me is doing their thinking for them. So I have an issue with this.
Rashmit here again from Huawei. No, I don't think we are trying to actually do their thinking for them. We are basically taking their requirements, and we are trying to do our homework in terms of putting a groundwork for our own protocols that we are proposing. Let's say we have 5 protocols that we are suggesting to be evaluated by 3GPP. This work is basically there to make sure that these protocols and approaches basically can do what 5G requirements ask any other approaches to actually do. If GTP can do it, the least those protocols can do is basically be at par with GTP. Forget about being better. But these are basically gives us the first pass test in terms of the other approaches that are being proposed we're not trying to actually tell to 3GPP that this is what you have to do or whatever. No, we are taking their specifications and we are trying to basically create a bar for ourselves so that when a new protocol or an approach comes in for evaluation by us, we basically have a bar to consider those protocols against, right? So that's the purpose of this work.
Okay. All right. So how many people have read this document? Okay. Thank you. I think that's a fair number of people. I think we need some discussions on the mailing list, based on if there are good amount of discussions, we'll be able to issue an adoption call at some point. Yeah.
Thank you very much.
Thank you. Next is Arashmit, optimized mobile user plane by Arashmit. Yeah. Kalyani, this is draft Kalyani, right? Okay. Is this on?
Yes.
Okay. So you have 15 minutes, Arashmit.
Hi, everyone. My name is Rashmit Akavane from Huawei. Along with my colleagues, we have been putting together a draft that talks about different protocols and approaches to address some of the 5G requirements. As Shunsuke mentioned in the previous one, what was that piece basically is what was missing in this piece, the requirements that we need to conduct or work with. This draft is basically considering to compare different protocols from the 3GPP requirements. So background, I guess you guys all already know about this. 3GPP has issued, the CT4 has issued a study item to us. There are references in there that you can take a look. The new revision of this draft has gone through many reviews, and we have done a lot of work in the conference calls and received comments. We received also comments from 101, and this new revision basically is a reflection of all those comments, and we are trying to address all the issues that came up during those reviews. Several protocols are basically being considered here, from SRv6 all the way to hybrid ICN, which is a relatively new one to the document. The document has been prepared as a submission for consideration of different protocols by 3GPP. And that's how we are positioning this. Again, we're not trying to actually tell 3GPP what to do. We are just presenting the facts, and we are trying to actually say these are from our perspective, these are the contenders that you might want to consider in your evaluation. The evaluation is not even ours. We're not trying to actually do the evaluation ourselves. We do, however, consider evaluating these protocols against the previous draft that Shunsuke and others are putting together. So what are the focuses of this new update? It basically focuses on 5G architecture from the mobility management perspective. Roaming architecture now has been added to the draft. You're considering the roaming architecture as well, and how these protocols basically behave in terms of roaming. Support for different mobility protocols within the operator networks and the slicing, for example. That's another consideration that we have made in the new revision. Again, the data player architecture model for N9, because the study item, this is very important, the study item that CT4 issued is only applicable to the N9 interface, the interface between the UPF. So N3, N6, N3, 4, N2, they are all out of the scope. We are only concentrating on the N9 interface for now. That's what is in scope. We have the last one is the last portion is a bit controversial, because we made classifications of the protocols. That debate is still ongoing, and we might have to revise it at the end of this. Reviewed approaches. So generally speaking, the first two actually are the probably the models that you're following. There are two basic models that we considered. One of them is interworking, and the other one is the integrated model. In the interworking model, the idea is to leave the 3GPP control plane intact. N4 basically will remain the same. N3 remains the same. And 4 and 6 will remain the same. And the only thing that you're changing is the N9. From the UPF's perspective, the idea is to make sure that they are still under the impression that they are doing GTP. They are connecting to each other with GTP, and we are dropping basically some sort of gateways in the middle to allow the operation to continue as it is today. One of the biggest objective is probably migration from existing network to the next. And this interworking model is aimed to actually address that. How you actually go from the existing GTP-based model to anything in the future, basically. That's the first. The second one is the integrated model, which basically talks about how UPFs will get integrated with the new protocols, and basically we start going toward the next generation of N9 in mobile network. The draft also, as I mentioned, has gone through some sort of classifications in terms of, these protocols. Some of them are locator based, some of them are lock ID, and some of them are ID based. Again, this is under debate whether we want to actually classify these protocols as such. There are many different classifications, and this might change as we go into the future, because again, something like SRv6 and Lisp can actually get classified as differently into the model, and that's why the debate is sort of continues. Last but not least, there's another draft that my colleague Shinsuke will talk about, which takes advantage of 3GPP own release 15 feature, which is called an uplink classifier. Again, this is another important aspect that we considered in this new draft, which basically allows us to fit the model into interworking. Essentially, when the new slices in 5G start appearing, we can use the uplink classifier as a filter at the G node B to separate the traffic. In this manner, if we have a blank canvas slice, we can basically set the N9 to a different approach or a different protocol only for that particular slice based on the filter that we put place in the ULCL. So this is again another approach toward the migration, basically, which is in any network we find that it's the most important part. You cannot turn on the switch and convert the old network to the new one just like that. Another good example is the use of ULCL, which basically allows us to apply any protocols in a smooth manner and migrate the network out. So now a little bit about one of the rest of the document basically goes through different approaches that we have considered. One of the approaches is an SRv6, which we are positioning as a possible protocol or approach for the N9 interface. The approach basically says that, okay, so if I have the GTP tunnel here, the first approach basically is addressing the interworking model, which allows us to drop the SRv6 gateways in the middle and use some of the existing drafts that are being worked on by Satoru and other people here to carry TE-IDs around and basically having a smooth migration toward new data plane. Once we do that, given that SRv6 gateways now can be viewed as network functions, these network functions can be actually pushed into the UPFs, and therefore will provide us with the integrated model if you want to go that way.
I have a question. My name is Uma. I'm with this document from the day one, last year, December, with Kalyani, but I'm not a co-author, I'm not a contributor in this document, but I'm aware of all the progression of this document. I'm aware of, I used to be in the offline calls. So my question is, SRv6 is good, very good choice, but only one comment. I like SRv6 because people, if I give a comment, people are thinking that it's not like that. It's good, but the problem with the drop-in GTP, drop-in replacement, the problem with that approach is you are mixing underlay with overlay, because you are putting TE-ID, ripping off the TE-ID from the GTPU header and encoding as IPv6 seed. The problem with that approach is you are forcing all underlays to be SRv6 and IPv6, which is not you intended. SR MPLS, there's a great data plane, which is SR, uses SR. So let's not dictate operators what they want to use. I talked to a couple of operators in Europe from HC working group point of view. So there are a lot of existing deployments using other than V6. Okay, so we need to be cognizant of that. Only that aspect. Otherwise, the document is great. This need to be corrected. I'll send a mail to mailing list. I should make this comment to Spring, so I'll send an email.
Okay, so this is a comparison document, right? This is not about one approach. So your comment is on one of the approach. I think please post a comment, and I think you guys should try to reflect that point.
Sure, absolutely. So we are actually this is something I talked offline with Duma as well, and we will sure consider this in our draft. There's some work that is going on the sideline to actually have interworking situation between SRv6 and MPLS and other networks as well. So they're coming down the pipes, and we're going to be, as they come in, we will basically put these things and beef up the document accordingly.
Right. So I think one important thing is, I think for every solution, because we are saying we are characterizing it, the feedback has to be incorporated, because
Absolutely, yeah.
Otherwise, if you send this to 3GPP, they say it's a biased view.
Absolutely, yeah.
Because these analysis documents, I want to be absolutely neutral.
Absolutely, yeah. So again, the essence is not basically to favor one approach with the other, because we are just presenting facts and what can be done using different approaches. It's the 3GPP that will pick up these draft and we'll take a look at it, and basically they can come back and say, okay, probably you need to actually give me some more information. I'm interested in this one. Please give me more information about this approach. So that's how we're looking at this whole thing. As I said, once we actually integrate the SRv6 into the UPFs, then we can actually start using other options like TE and introduce entropy and for example, function chaining into the place. You got to remember though, function chaining is something that we see in the IETF as something important. 3GPP might not actually look at it from although the specifications allow for multiple UPFs in the standards. However, we might not go beyond the current SGW and PGW in the network anytime soon. So again, some of these things might be a bit futuristic for now. Then, of course, the support for slicing will come up. We'll support the slicing using the SRv6, and then the next thing is toward fixed mobile convergence with ID lock. The idea is basically to support ID lock with SRv6, which again has two models, the interworking model and the integrated model that can be done either way.
Hanno Flint from Nokia. This was about N9 interface, wasn't it?
Yes.
Wasn't it? Service chaining is on which interface?
N9.
No, N6.
No, N9. Because you can actually pick up UPFs and put them in between. And from once you actually have multiple UPFs, then you're actually talking about service chaining. So because today you will have GTPs going from one UPF to another UPF to another UPF.
We are not reading the same documents, I'm afraid.
Well, you're talking about service chaining. I'm talking about chaining in general. Whenever you actually drop more than one UPFs in the data plane, you will have to actually consider another GTP in the middle. So this is supposed to actually address that issue.
John,
John,
just to respond to the previous comment. The current specifications say that chaining will be on N6 and not on N9. It may change later, but the current 3GPP specifications are on N6.
So let me give you another comment. So today we have a whole bunch of functions that are actually being done within the SGW and PGW. If you want to actually separate those functions and put them in their own UPFs, then you have to actually steer traffic to those things. Right? So that's where you need more tunnels, and that's where service chaining aspect of SRv6 come to the picture.
I'm not saying that this is not the right approach or it should not be followed or anything, but just to say that that's the status in 3GPP.
So I think, quick comments, because
quick comment. Actually, I agree with both what the guys' responses. And service chaining is an N6 interface. You cannot characterize N9 interface as service chaining because re-encapsulation happens at the ULCL UPF, that is the branch point UPF. That's not service chaining.
So let's discuss that. So I think where is on the GA interface, or where is the service?
I think part of the problem is the terminology. I think we are distinguishing between service chaining and function chaining. So service chaining, you're absolutely right, N6. But at least myself, I'm considering function chaining as a form of service chaining as well. So that's why I think that we can actually put that apply that concept into the N9 as well.
Just a quick note here. Service chaining in a services context is more like service programming, and it is broader concept for network virtualization and other things. So when we talk here, it's a broader context in terms of service programming, where you can do network virtualization as well, which will be part of this connectivity.
Thank you. Marco, very quick comment.
Very quick comment. So I was in some calls at the very beginning of this work, and I understand very well why you focus on N9 and not on 6, rule out N6. So now you bring in service chaining on N9, which I also think it's an N6 issue. So I was wondering, and at the beginning I asked Kalyani, why not including N6 into that work? Because if you, so you still assume the PDU session anchor, which is one endpoint of N9, is a central anchor. So if you move that anchor more and more to the edge, you mitigate the impact of N9, but you move the problems to N6, right? Which is in the context of the MFA draft. So it's related problems. And now if you introduce service chaining, it applies to both, to N9 and N6. So if you don't introduce it to the draft, let's at least consider it in the discussion, what happens if you move the PDU session anchor to the edge and how to solve the problems in N6.
That is exactly what I call in this slide. If you can see, I didn't call it service chaining at all. I call it chaining, right? So to us, at least to me, it's the function chaining that you can add. Today, if you look at the SGW and PGW, the fact that these guys are actually tied up together, it's basically create a chain of functions, right? So you can actually separate those functions and put them in different boxes, and basically now you have a traffic steering problem in your hand, that you have to actually take the traffic from one point to the other point to the other point to the other point, all the way to the PGW final function. That's what we consider chaining. So it's not the service chaining that N6 is trying to address. It's basically the multitude of functions that are being available in PGW and SGW, and there is a way to actually separate those functions.
To consider chaining what's the UPF and the uplink classifier is today to distribute between multiple nodes and use service chaining.
That's right. Yeah. So now you will have to face the fact that now you have to basically steer traffic between these points of these function points.
I see.
Okay, I think we should wrapping this up. Maybe one more minute. Yeah.
So this is Alberto Rodriguez from Cisco. I'm going to go through the log ID split approaches and the rest of the document. First, Lisp, locator ID separation protocol. I would like to clarify something here because we are still hearing some misunderstanding on this. So the Lisp working group was recharted a couple of years ago, and one of the main topics of that recharting was to separate the Lisp control plane from the Lisp data plane. That work is complete now. The documents are about to become standards. So the RFCBs that are mentioned on the document are about to become standards. And today, when someone says that it's using Lisp, that doesn't necessarily mean that they're using the Lisp data plane. So as said on the first one on the slides, today you can use the Lisp control plane to support many different data planes, and actually there are a few documents that have been recently published that go in detail over that. So one thing to notice here is that the Lisp control plane has been around for over 10 years now, and is pretty mature, and it's been used in quite large deployments. So there are a lot of operational experience with this protocol, and it tackles mobility aspects deeply in the protocol. So there are several documents that go in detail over different aspects of mobility within Lisp. There is one in particular on Lisp for mobile networks. And then on the Lisp data plane, that's something you can use with the Lisp control plane, but it's not the only option. Basically, in the data plane, what you have is IP and IP encapsulation with a fixed 16 bytes here in the middle using UDP encapsulation and all the classical stuff. So two recent documents that are of relevance for this work and in general for this working group are the Lisp control plane for ILA. ILA will talk a bit afterwards, and the Lisp control plane for SRv6 that we have recently published. So the last one, Lisp control plane for SRv6, we're going to present it on the Lisp working group on Thursday. So you guys are free to come and comment there. And then on the right side of this slide, you can see the models that Erasmus was talking about, the integrated and interworking models from an ID log perspective. So you can have the ID log functionality integrated into the UPS directly, or you can have them as gateways in the network.
I think, Alberto, I think we should wrap this up. Yeah.
So can I continue for just a moment? So ILA, another ID log protocol, it does address writing instead of encapsulation. There are a bunch of documents that this is driven by Tom Herbert, and I'm sure that he will be more than happy to discuss it with you. Hybrid ICN, Jordan and Luca will present later today here. Hybrid ICN for mobility. This slide is really nice, so I invite you to take a look in details on your own time. You can use different slices to have all these approaches coexisting if you wish to do so. And finally, we are hoping to get feedback from 3 weekends.
Okay, thank you, Alberto. Dino?
Just one quick clarification for the 3 GPP people in the world, in the room, and the world, I guess. The List Mobile Networks spec is speccing the N3, N6, and N9 interface. And the most important feature is to get shortest paths between G node Bs, so 2 UEs have the lowest latency. That's what the focus is on. So when we did the comparison among and focused on N9, we just want to make it clear that the list proposal is showing all those interfaces.
Okay, thank you, Dino. I think next is Shinkai-san. Which one is that? Transported over there. ID the coexistence, yeah. Okay, so this is the coexistence of 5Gs with ID lock separation architectures. Shinsuke-san.
Yeah.
Yeah, you have roughly 1 second. You have 10 minutes, yeah.
Okay, so hello everyone, Shinsuke again. So in this presentation, I will introduce an approach to introduce ID lock separation architecture into 5G system. Firstly, I will introduce the background and purpose of this this approach. So as you already know, the ID lock separation protocols is expected to enhance mobility in mobile network, and we are proceeding to introduce such protocols to 3GPP. On the other, meanwhile, the specification of 5G release 15 is already fixed, and 3GPP may dislike to change any interfaces. So this internet draft provides an approach to introduce ID lock separation architecture without any impact to the 5G specs. So this slide shows the overview and summary of this document. So this approach uses uplink classifier, which is a fundamental function of UPF, and enables to introduce ID lock architecture with no or low impact to the 5G specifications. And this will be able to provide a good migration path to the UPF support ID lock mechanism natively. So this is the architecture model which this approach has as an assumption. So in this network model, several UPFs are distributed geographically for make use cases such as connected car, and most of traffic conveyed with GTPU. These following 2 slides shows the challenges on the such network. So in this network, central UPF will be an anchor for the traffic forwarding. So in the UE to UE communication, every traffic is forwarded to the central UPF, and forwarded to the destination UPF. So this may cause additional delay. This figure shows challenges in the UE to distributed data network communication. So, if UE moved to another site during any session, so the traffic forwarded to the network function deployed in the data network via central UPF. It's also may cause additional delay. So this proposal provides a solution to reduce such additional delay. So this slide shows a key concept of this approach. So this approach uses the uplink classifier, and uplink classifier diverts just traffic which needs to be forwarded with anchorless path to the ID-lock domain as external network. So this is an overview of this architecture. So ID-lock node is deployed between distributed UPF and data network. And ULCL monitors the traffic and diverts required traffic. And ID-lock node receives the packet and forwarded to the appropriate destination ID-lock node. So this enables to provide anchorless forwarding. This slide shows user plane and control plane features of this approach. This approach allows to use every user plane protocol, such as SRv6 and even GTPU or control plane. In the control plane, some interaction will be required. Interaction between ID-lock mapping system and SMF will be required because for indicating the location of UE to the mapping system. So SMF should indicate such information to the ID-lock mapping system. Do you have any?
John, I have a question on the previous slide. This is showing the uplink classifier being used to forward to the destination. How would the programming make sure that it takes the same path on the downlink?
For example, so uplink classifier look up the destination address, and if the destination address is one of ID space of its own
That's
operation.
okay. But on the reverse path, on the way back, it will go back to wherever the IP address is anchored, or which is the default gateway.
Reverse traffic?
On the downlink.
Downlink?
Yeah. The downlink, the packet is going to take the path to the gateway where the IP address is, the default gateway. Right?
So the question is, where is the IP address anchored? I think John's question is which, I think that's.
Yeah, that's.
So from the downlink traffic from internet or central data network is forwarded with GTPU, so existing 5G system.
I mean, I think that what I see in 23501, at least they put a couple of notes. Note 0 in this context is saying use NAT. And maybe that's not such a good idea for IPv6. And then there's a note 4, which says it's out of scope. So I think there's some problem, and I was wondering if you had thought about that. Maybe we can take
Maybe John, why don't you, I think good comment. Why don't you post it in the mailer? Yeah, please.
Sorry, did I just understand your answer correctly? This only applies to the uplink. It doesn't apply to the downlink. The downlink just follows whatever's happening without this. Did I get that right?
I'll let him clarify. Yeah.
I think they want, I mean, from the 3GPP side, you want the same path. You don't want the uplink to go on one way and downlink to go another way.
Yeah. This approach focuses on just on the uplink.
Yes, therefore.
couple of things. So yes, you're absolutely right. We have to actually work on this and make sure we have a symmetrical path between the uplink and downlink. The other thing is that Shunsuke sort of alluded to anchorless mobility. I would say that for anchorless mobility, there are far more work to be done. Which the data path probably is the least problematic. With anchorless mobility, we have to consider a whole bunch of different functions that are actually being applied at the service gateway and the packet gateway, and as long as we haven't solved those issues, the path to anchorless mobility is very difficult to actually achieve. So, but I agree that we have to actually work on this approach and see how we can actually come up with a solution to make the both paths symmetrical. Because if we were going for URLC, for example, that's pretty much the way we have to go.
Okay, Lyle, quick comment. Otherwise, you'll be running into
just a question, and I'll take the answer offline. The comment was made that 3GPP wanted a symmetrical path. My question is, is that a hard requirement? And if so, where can we get that information? Because that would really guide a lot of us looking at solutions to make sure we're not entertaining anything that does not meet that base requirement.
Good point. Yeah. I think Lyle's question was, is there a hard requirement? Did 3GPP state this requirement? That was his question. But yeah.
So this slide shows the conclusion of this approach. So this approach uses uplink classifier and provide a way to introduce ID lock without any impact for 5GS. And this will be a preferable migration path until 5GS natively support ID locks. So,
Dino?
Are you done? I don't want to interrupt. You're done. I just want to make a comment on the symmetric comment previously. With the mapping system, you can get symmetric or asymmetric depending on what set of locators you register the mapping system. So no matter what the requirement is, I think with a mapping system-based solution, we could support either one.
Yep. Thank you.
Rashmi, again, I want to build up on what Dino just said. So we might have to actually just clarify this in the new version of the draft and basically show how mapping system can actually solve this problem in the new version of the draft.
Okay. Thank you. So finally, I will mention the next steps.
Yeah.
So
feedback. Yeah, this is good. Yeah.
So we need a more review and feedback, and we believe that this is an option to introduce a ID lock separation protocol into 5G system. So, and Kalyani's draft already includes this approach as an option. So, and if possible, we would like to make this be one of the liaison reply from DMN working group.
Okay. Thank you, Shunki-san. You got a lot of good comments. I think, how many people have read this document? Okay. So, okay, yeah, few people. I think I think we want few more discussions and all of that before we even issue an adoption call. But I think two key points. I think, you got a lot of feedback. That's one thing already. Right. Second thing, I think regarding the LS reply, we will not be able to refer to this document at this point because it's not a working group document, it's a specific solution. Yeah, so, but I think you should get some feedback from the reviewers and then continue to update the document, and maybe hopefully next IETF we can issue an adoption call. Dino?
I have a general question for the chairs in the working group. Does the working group think that there's too many proposals that are being put forward to CT4? Should we have more? Should we have less? It would be nice to hear opinions.
Yeah, I think from our point of view, I think we talked in the past as well. We are going to, I think, pick up individual solutions or approaches, and we are going to standardize them. Right. Again, as we discussed before, we are not saying less or more. Whatever, like in IPv6 transition is a great example. IETF ended up with a bunch of approaches, right? So if somebody can justify the work, and if there's support for the work, and if this is within the charter, we'll absolutely standardize it.
I wanted to ask the question of 3GPP. Maybe there's a
Oh,
comment
okay,
there.
sorry, that was okay.
No, I wanted to hear from the working group. But...
Okay. Thank you. So I think you have two types of documents. The one is where you evaluate our stuff from 3GPP. There you just can't expect too much reply from the 3GPP. We cannot correct your papers, right? You're trying to do your papers here in a consolidated manner, and we cannot just come down and say this is wrong or this should be written in a different way or so on. And I think it's also not beneficial for you that we spending in 3GPP too much time on reviewing your analysis of our documents. That would be not leading to any goal. So don't expect too much from us on that part. On the alternative solutions to GTPU that you have, we have a study item now. Of course, if we are overloaded, study items will always take second priority. So we will have a lot of load in release 16. Nevertheless, I think this is now understood that this is important and that many companies are pushing for that. So yes, bring us proposals and bring us different proposals. We will evaluate them and we will most likely come back with questions. But one thing in general, and that is really now said as sort of a private person here, if you want to get your proposal to get more attention in 3GPP, please consider to come to CT4 and work there with us. This is a crucial time now. If you think your solution is the right one to go, then please bring your input not only here, but also come to CT4 and explain the background of your ideas there. Thank you.
Great feedback. Thank you. Yeah, I think last presentation, Ashwin, last presentation is yours, so you're running into your time.
Quick comment on what Dino was saying. So maybe we can actually use the analysis draft as a way to actually trim down the list, maybe. So first we evaluate it against what we did in terms of analysis, and then we say, okay, which one of these protocols is stand our own basically sticks, and then we can probably trim the number of protocols that way.
Kent, very quick comment.
Sorry, this is Kent Leong. Actually, I mean, that was a big comment there earlier, right? I just want to skip it, which is that this solves the easier problem, right, of the anchor list. But I wasn't sure if anybody's addressing all the other key requirements, right, which is really what the anchor model provides, the services for quals, charging, quota, a whole bunch of stuff that's happening. And when you move that out of the way, who is actually addressing that? And I think even when we solve this problem, it's not, that usability has become the key factor. So until somebody brings that in and address it, in some ways, I think that will then address some of these issues, right? So again, it was more of a comment at this point. So.
Right. I guess the implications to the control plane needs to be studied. Yeah, I agree with that. Okay, thank you so much. Okay. I think the next one is, I think UMA, Transport Network Aware Mobility for 5G. What is it? Transport Network. Yeah, unfortunately, 5 minutes. Yeah.
Okay, my name is Uma. I'm just quickly, because of 5 minutes, I'll quickly run through it. I will let you read my draft. This is put forth by me and a couple of folks. So I'm not going to talk about the background. We talked about, multiple drafts like the analysis draft, GTPU analysis draft, and, various proposals. So we are talking about N9 interface here. So the background is for the N9 and N3 and N6, whatever it is. So the thing is, what I'm talking about here is, so various SSTs, like 3GPP has defined service slice types as indicated here. There are various traffic types for various PDU sessions, which are mission critical or real time. Today it's only EMBB for fixed wireless deployments, initially for 5G. But in future, if you go to the different PDU sessions where low latency and mission critical applications are there, today for transport network is considered not considered in the middle, either it on N3 or N9, there will be significant problem that all the gains made in NR, 5G NR or in the virtualized core will be evaporated quickly. And the second part of it is, sorry, can you make this? The second part of it is how various transport technologies IETF developed over a period of 20 years, how these can be leveraged effectively to integrate this. Some of the PDU sessions can be leveraged to integrate with the 5G radio access network and the core network. So the objective is create a reference model in the service-based interface and how IETF technologies can be integrated in this. And if you have, it also talks about clear mapping between PDU sessions, 3GPP PDU sessions and various IETF transport technologies. Also specifically talks about preferred path routing, which builds on SR, and it helps the goal of here of optimized transport. And I will talk quickly about that. And also other technologies like SRv6, SR MPLS, or RSVPT, how this can be integrated into the 5G architecture. This approach doesn't replace GTPU. It works with GTPU on N3 interface, and it works with any encapsulation approach you choose on N9 interface, including GTPU. So this is the service-based architecture, various CUPS architecture. Basically, its control plane is separated and data plane is separated. So, which is all good. Because of the coverage area, P gateway is to be 1,000 kilometers, moved to the 200 kilometers range because of UPF. This introduced a new problem. So this new concept of UPF mobility has come in. So there are two things that are being solved there. I'll talk about SSA mode 1, mode 2, mode 3 later. So, but the thing is, the most important point here is how do you integrate the transport network in between N3 interface and N9 interface? There are two ways that can be done. One is discrete approach, where underlying transport network is, just it's independent of 5G core and access, which is deployed today for 4G slices. Basically, we have only two bearers there, only default and voice voice bearer. So it's easy there. So there's not hard critical requirements. In the discrete approach, your transport network, complete links and node information, it fed into the central place, and it's continuously monitored, and path selection happens based on the UDP source port. The GTP, once GTP packet is encapsulated with GTPU, source port based selection of the transport will happen. This is being deployed in current couple of deployments, including in US and UK and couple of places actually. So what I'm proposing is an integrated approach where this is not required for all the PDU sessions, where this mission critical and real-time sensitive applications. The approach is you put the TNF transport network function into the service-based interface and create two interfaces here. I showed cell site router, which is apart from G node B, which is front hall. It can be in some places, a cell site router can be part of the G node B. So this northbound interface from the UPF, ULCL UPF or branch point UPF or the anchor UPF, the southbound interface to the cell site router. So this complete TNF, the advantage of putting into the SPA is when the mobility happens, resources on the transport network can be factored for some of the PDU sessions. So what are the TNF functionalities I'm looking here? So the NSSI, what the 23501 defined, can get the transport network information while making the decision, including mobility and XN mobility or N2 mobility. And for wherever it is required for some of the slices, some of the 5 QIs, this information can be used to making the mobility decisions. And for the regular non-mobility cases, for a service request, idle to active, active to idle case also, whether you have transport network resources that there or not there, you can be verified. And yeah, next.
I think we are out of time. Just for your final thoughts.
Okay, next slide. I was talking about, just give me one. Okay. I was talking about various technologies, various transport technologies, including RSVPTE, including SRMPLS, including SRv6, including the optimizations PPR can bring in, have been discussed in the summary. This proposal leverages the existing IETF technologies to get the benefits to the 5G, some of the PDU sessions. It works with any model, like, any overlays, IPv4, V6, V4, V6, Ethernet unstructured to the any backhaul transport. This is important because to protect the existing investments of some of the operators.
Thank you, Uma. I think it's a new document. It was posted only one day back, so we are not going to ask who read it, right? But so if there's more discussions next time, we'll, so we are not taking any questions. We are out of time, sorry. Okay. So thank you, Uma. Yeah.
Can I just make one comment? While
we are
this was discussed in LSR working group yesterday, and there were a lot of
hybrid
comments.
ICM look.
It's like the PPR is really a non-starter.
This one, right?
It needs to be discussed outside this working group with Spring and LSR more. There were some comments posted as well.
I presented the PPR, technology-based technology in LSR, how it can enable optimization for SR, MPLS, and SRv6. And there are some questions going on in a Spring working group. I am answering that.
Okay. Sorry. It's loading.
So in the meantime, my
Why
name
don't
is
you start your presentation? Yeah.
Jordan Auger from Cisco, and in this presentation, I wanted to give you an overview of how we propose to manage anchorless mobility through the use of hybrid ICN. So hybrid ICN has been quickly introduced by Ara Schmidt in his previous presentation, and it belongs to a class of approaches which is ID-based, which means that this come in contrast. Thank you.
Yeah.
Oops. So this come in contrast with the typical use of IP addresses, which are interpreted as locators by typical IP networks, and mobility is then built on top through the use of tunnels and anchoring of communication through specific nodes. So following that, we have seen approaches based on local ID separation, which have been proven to be interesting in terms of mobility management. But they have one common characteristic, is that they use a mapping system to bind the IDs and the locators. And this has been shown sometimes to be challenging to operate because it introduces some latency for resolution or some bindings to coordinate the caches at very high frequency. In this proposal, we try to move the IDs behind local ID separation one step further and propose to remove the mapping and forward the request directly on identifiers. So this is not a new idea, and it has been already introduced in a draft I refer in the slides. And it's a concept of native ID oriented, except that in this draft, there was no real implementation and it was only a wished feature. So the interest of this ID-based architecture is that you don't have the need for a data plane anchor nor for a control plane anchor. How we propose to do it is by applying ICN principles, and we're interested especially in the hybrid ICN proposal, which is an implementation of ICN within IP. And Luca gave a presentation yesterday in Interia about this technology. So ICN within IP, it's basically an integration of all ICN features inside regular IP protocols, with the only compromise that we encode names inside IPv6 addresses. So this transparent integration is really interesting in the sense that we don't need all nodes to be HICN enabled, and we have only a subset of nodes which are HICN enabled, and the rest of the network can be plain IP and interoperate nicely with HICN. In terms of mobility, what is interesting is that hybrid ICN is a request-reply communication pattern, and you have a consumer requesting some data, and this data is identified by its name identifier, and this request is propagated in a hop-by-hop fashion by the routers using the fibs, and it leaves some state every time it's forwarded by a router. And this state is used to forward the response back to the originator, and at the same time, it leaves some temporary cache in the network routers it encounters. So thanks to this request-reply pattern, mobility of the consumers is native because it's simply a matter of resharing, pending interest, or next request for data, so as to continue the communication without an interruption or the need to renegotiate a source IP or to transfer a context. Producer mobility is not supported natively, and the draft tries to describe the mechanisms we use to support it. So very shortly, what we do is to use distributed forwarding updates to manage mobility, and this has been previously proposed in MapMe protocol for the ICN context in ICNRG. And the key idea is to use to repair the path to reach the producer through data plane mechanism. And again, this concept is not new, and actually I borrowed the title of the slide from a paper at NSDI a few years ago that proposed to use data plane mechanisms to ensure connectivity. And I proposed this to allow the latency to contact the control plane and to be more efficient in restoring connectivity. They propose it for link failures. We propose it for mobility, and our scheme is doing lightweight fib upgrade process. What is important in our scheme is that both forward and mobility operations are purely based on IDs or names in the case of hybrid ICN. We have no interaction with the control plane, no mapping to contact or update, and no new node to deploy or provision to manage mobility. So it should remove most of the challenges in operating mobility. So I won't describe much more, but the key aspects to remember is that this scheme is fully anchorless and that mobility is handled at layer 3, which makes it very convenient for heterogeneous network support. In the draft, you will find pointers to some documents supporting the performance of the scheme for scaling of flow performance, plus some optimization we do for latency-sensitive traffic. In the rest of this presentation, I will illustrate some of the benefits in the context of deployments, which is the object of the second draft we propose, and we focused mainly on the 3GPP architecture. So I won't go into detail for 3GPP, but just illustrate how we benefit from hybrid ICN in this context.
So Jordan, you should be wrapping it up. I think a little bit of short, sorry.
Thank you. Yeah. So the first benefits, they originate from the use of a request reply pattern, and it's simply the matter of ratioing interest, and at the same time, it's sufficient for you to load balance your request on many accesses to benefit from native multi-homing or multipass. The second benefits are originating from the use of intermediate caches in pass from the routers, and this allows low latency and native multicasting of the request because a router is able to answer on behalf of a consumer. The second type of benefits originate from the native anchorless properties of the scheme, and we obtain this when we use, for example, in 3GPP HICN in place of the GDP tunnels, and this allows anchorless mobility and offloading of edge communication at the edge of the network. So I won't detail that. So of course, both benefits from HICN and for the use of ID-based mobility can be combined are what we propose. We have a discussion in the draft about partial insertion strategies where we can have HICN on a subset of nodes or use SRv6 in between HICN to extend the reach of the proposal. We require HICN in endpoints, but we try to make the insertion really minimal through easy-to-use implementation, and non-HICN traffic can also benefit from the mobility pattern based on IDs. So to conclude, I would say that we have proposed a new paradigm based purely on identifiers. We build on hybrid ICN. It brings us native consumer mobility, and we have made a proposal for lightweight producer mobility based on data plane updates. So we analyze several deployment trade-offs and the different benefits we gain. And as a conclusion, I would say it's a general purpose architecture with nice anchorless and net support abilities, and it offers the possibility to insert HICN and benefit really for these new transport features. Thank you.
Okay, so how many people have read this document? Okay, thank you. I think we need a few more discussions. Yeah, okay. Thank you. I think next is SRv6 box. I think Mark, what is which one is that? Transport.
Hi, I'm Mark Bales.
Just 1 second, actually. No, not that one. Probably the last one. The SRv6 data plane, right?
We can talk to the last one.
Is this the one?
I know.
Oh, yeah, draft code. Okay, the title.
This is a follow-up on Pablo's document for the SRv6 mobile POCs. This is specifically around the MCORD project. Okay, I'm going to skip that. We'll go back to testing. The MCORD project that he mentioned in his previous presentation today was an MCORD project called C3PO, which is an LTE 4G open source core. Essentially what we're trying to do in this POC is to establish the inner working of an SRv6 underlay for an an evolved EPC core in the 3GPP standards. Essentially, we built an underlay for it, and then went through the process of interworking IPv4 GTP across an SRv6 network, just to prove that we have a transition path. So back to the traffic environment, we did generate, we used 25 users and 10,000 packets per second to prove out the functionality. The C3PO provide the MCORD project C3PO provided the EPC core, and we used the VPP software to create 3 nodes to provide the interworking underlay. So we ran 2 scenarios through the EPC core. One was policy-based encapsulation of the IPv4 GTP traffic, ran into jumbo frame problems as you would expect. And then we did the interworking with IPv4 GTP tunnels with the TID stored in the the SRv6 headers to get the interworking, so we didn't and rebuild the header at the other end. And both of those were successful. We haven't got to the point where we've been able to test this at line rate, but the software we're using from the MCORD as well as the VPP software aren't quite ready for production and aren't released to the general public just yet, but they will be shortly. The software is available here. That's the generic software. This is where we would expect these to be after they get generally released if you wish to go in and try this yourself. Like I said, both scenarios were successful in testing. Be aware that the jumbo frames will cause you problems if you're just trying to do straight encapsulation. But the IPv4 GTP policy-based interworking was successful as well. C3PO code release, we're expecting one here in the next couple days. Actually, that's not 718, yeah, it is 718, sorry. Our next steps are to go back and redo the baseline testing and try to push this towards line rate just to see how the software performs. And the contributors to the solution are listed there. If you need any information or detailed help, feel free to reach out to us.
Okay, thank you, Mark. I think there's one last related presentation, a service exponent that we're going to skip.
I'll just go on the
sure.
mic and actually talk about it. So as Sri talked about it, there's another demo that you're putting together with using the OAI open source software. So that one will be complementary to what Mark was just talking about. And there are plans to actually integrate the two demos together, and we're in the planning stage of that. So the objective is again for the OAI model, for the OAI open source to actually be used as a base for demoing SRv6 gateways, as showed in the previous presentation. The problem is that the OAI basically right now only supports the combined SGW and PGW, so there's not really an N9 interface to actually do the work. So we're basically focusing our effort to showing it on the N3, and then we see whether we can actually separate the SGW from the PGW inside the OAI. And that demo will follow the SRv6 mobility for uplane mobility to basically get the TEID from the GTP tunnels and transfer them over SID across the network between the eNode B and the SGW and PGW. So if you need more information, just come talk to me. I can elaborate some more.
Okay, thank you, Ashmit. Thank you, Mark. Thanks. With that, I think this is good work in general. Anything about implementation deployments, we want that feedback. I think this is great stuff. With that, we'll conclude this meeting. Thanks, everyone. Yeah, I think blue sheets. I think there should be one more blue sheets. Who has it, please? Yeah, thank you. Thanks, folks. Yeah. His dad is not well, so he had to go back to India. So his dad is not well. His father is not well. Yeah.
Thank you.
Both are here? Oh, okay.
So, hi, I'm not